All right, probability and counting techniques. Here's our question. We've already drawn out our little diagram of it. We have 2 brothers in a race with 5 other friends. How many ways can they end up in lanes next to each other? Okay, so we've colored the 2 brothers to be in black, and all of the friends are in red here, and we have our lanes. So we'll count them out. 1, 2, 3, 4, 5, 6, 7. How many ways can these 2 brothers end up beside each other? So our brothers, in the case right now, are beside each other. I've set them up to be in lanes 1 and 2. We're going to go on the assumption, I've drawn numbers in here, 1 and 2, that friend 1, say Bob, let's say option 2, and I'll give us an actual numeric value, but let's say we move the 2 brothers over to lane 2 and 3, and it's Bob here. He's friend number 1. Okay, we're going to say it makes no difference if Bob is here or Jim. He's friend 2. That the order of the friends doesn't matter. It's just where the brothers are going to end up in lanes. So it doesn't matter what the rest of the order of that friends is. Okay. When we say that order doesn't matter, then we're no longer working with the idea of permutations, right? Because order doesn't matter here, so we're not using permutations. We're talking about combinations. So what I want us to do is I want us to think of the 2 brothers here as just one position. Because they have to be beside each other, that actually reduces our number of lanes. So I'll put in green. That's now lane 1, lane 2, lane 3, lane 4, lane 5, and lane 6. And if you notice on top, I've kind of put pairings together. You'll notice again there's also now only really 6 options. So I had that one pair, option 1, option 2, option 3, option 4, if we're getting messy, option 5. Did I move somebody? Oh no. And option 6. So that's the idea of only having 6 lanes now. So really there's only 6 different options here. Okay? Because now that we have them as one person, you essentially can put them in 1 or 2 or 3 or 4 or 5 or 6 options. And what that is because they're now one person, there are 6 options. How many different ways can we choose one person out of the 6? We know that 6 choose 1 is the value of 6 if you put it into your calculator, right? I guess maybe I should show that over here. Do I have combinations? Oh yes, I think it's combination 6 choose 1. Ah, nuts, that's not the wording for it. Okay, I'll figure it out after. Our other one though, this is probability. So these are all the ways that they can be chosen, right? This is all the ways that we can choose these guys. But how many possibilities are there? Jeez. That's our major question here. How many possibilities are there? Well, let's go back. Remember, it was 2 brothers, and these 2 brothers are being put into 7 different lanes. So there's a total of 7 options, and there's 2 individuals. How many different ways can we place these 2 individuals out of the total of 7 options? And that is another combination. There's 7 choose 2 in that case. So 7 choose 2 ends up being the value of 21 when we put it in. And we can reduce this fraction if we divide the top and the bottom of the fraction by the value of 3. Your probability is 2 in 7. So there is a 2 in 7 chance that the brothers will end up paired beside each other in a race with 5 other friends. Okay. Okay, so now it's a lesson in numerics. I just put, like you said, combination. You have to spell out the whole word. Combination. 6 choose 1.
Yes.
Oh yes, thank you. There we go. So that's 6, and then I can actually take the answer from above and just manipulate it. 7 choose 2, 21, and 6 divide 21 is our probability. Yes, we can copy and paste it in here. Oh, I love this copy and pasting. I'm so glad I found this new calculator. Let's paste it in.
Yeah,
7 over 2 is, there's our probability. So about 28.5% if they want it as a decimal, right? We move it over to 28.57% that the brothers are going to end up in lanes that are beside each other.